Welcome to Lecture 4 on Unit 2 Slope Deflection Method in Structural Analysis 1. So in this lecture we are going to apply the slope deflection concept to solve the continuous beams with sinking supports. So the reference for this lecture is I have taken from Structural Analysis Volume 1 book by Dr. R. Vaidyanathan and Dr. P. Perumal from page number 63 to 66. So if you see here, this is the problem which we are going to solve in this lecture 4. So analyze the continuous beam shown in figure by slope deflection method. The supports B and C. So if you see here, the supports B and supports C is sinking by 10 mm and 5 mm respectively. That is, support B is sinking by 10 mm. So this is 10 mm. And support C is sinking by 5 mm. So this is the condition they have which they have given. This is sinking by 5 mm. And if you see, they have given support D rotates through an anti-clockwise angle. So this is going to rotate in this direction and the value is 0.1 radian. So they have given the values of E and I, that is E and I is constant through the beam, and they have given the value of E as 2 into 10 power 5 megapascal. So we know that megapascal means Newton per mm square. So 2 into 10 power 5 Newton per mm square, and I equal to 4 into 10 power 7 mm power 4. We need to sketch the bending moment diagram. So remember that the B is sinking by 10 mm and C is sinking by 5 mm and D is having a rotation of 0.1 radian in anti-clockwise direction. So we will solve this problem in a clear way now.
So we are going to solve the problem which I have shown in the PPT. So they have given the problem, that is we are having 4 supports, that is A, B, C and D, and we are having 3 spans A, B, B, C and C D. Each span is 6 meter length. And they have given B sinks by, that is B support is getting sinked by 10 mm, it is moving down, and C is sinking by 5 mm, it is moving down by 5 mm, and the D has an anti-clockwise rotation, that is if you see here, B is coming down by 10 mm and C is coming down by 5 mm, and if you see the support, that is this CD support, D is getting rotated in this direction. If you see, if you calculate this is 0.1 radian. So this is what they have given in the problem. That is B is sinking by 10 mm and C is sinking by 5 mm and D is having an anti-clockwise rotation of 0.1 radian. And what we need to do, we need to calculate the bending moment diagram. So we know that the first step in slope deflection method is we need to find the fixed end moment. So here if you see, they haven't provided any load. Since there is no load acting on the beam, we know that the fixed end moment will be 0. That is M of AB equal to M of BA equal to M of BC equal to M of CB equal to M of CD equal to M of DC. These all fixed end moments will be 0. So what is the second step in slope deflection method? We need to write the slope deflection equation. So here if you see, I have written the slope deflection equation for first for member AB. Let us consider this as member AB. So if I write AB, we will have 2 moments, that is MAB and MBA. First I am writing for MAB. So MAB equal to M of AB plus 4EA theta A by L plus 2EA theta B by L plus 6EA delta divided by L square. Until now we have seen the delta value will become 0 because there is no sinking of the support. But in this problem they have provided the sinking, so we will have the delta value. So next M of AB value, we know that since there is no load acting on the structure, we are having the fixed end moment as 0. So I am commonly taking the 2EA by L, because if you see in each and every time 2EA by L is common. So I commonly taking 2EA by L here. So remaining 2 theta A plus theta B plus 3 2EA by L I have taken out. So 3 into delta. So sinking is 10 mm. It is downwards. So here if you see, you need to understand. So let us consider a beam like this. So let us take this section AB. So we are considering the AB section. Then they have given that the B is sinking by a distance of 10 mm. So it will be like this. So this value is nothing but, this is nothing but 10 mm. So this value is 10 mm. So if a beam is like this, then it need to come downwards in the right hand side. We know that in the sign convention we are saying if the right support goes down when compared to the left support, then it is negative. If the right support goes upwards when compared to the left side, then it is positive. அதாவது ஒண்ணு இல்ல, வலது சைடு சப்போர்ட், அதாவது இடது பக்க சப்போர்ட்டால கம்பேர் பண்றோம். வலது பக்க சப்போர்ட் கீழே வந்தா அது நெகட்டிவ். அதே வலது பக்கம் வந்து இடது பக்கத்தோட மேல போச்சுன்னா அது வந்து பாசிட்டிவ். So here if you see, if a beam needs to come down like this, then we need to provide a rotation. That is, the rotation should be in anti-clockwise direction. Here the rotation should be in also anti-clockwise direction. So if we provide a rotation in the anti-clockwise direction, then only this side, the beam on the right hand side will come downwards. So we know that the anti-clockwise rotation is minus. If you want to understand the basic concept, then you can go for this rotation. Or if you want to simply, if you need to understand, sir, what will be the value of minus, how I can give simply the minus or plus for the sinking. For that you can follow this step, that is, if the right support comes down when compared with the left support, then it is negative. So if the right support goes upwards when compared to the left side, then it is positive. அதாவது மேல போனா பாசிட்டிவ், கீழே வந்தா நெகட்டிவ். Remember that, then you can simply apply the condition. So here if you see 3 into minus 10, because they have given that B sinks by 10 mm. So if you see this, it will get coming down when compared to the left hand side support. That is, if you compare with A, B is getting down or getting sinked by 10 mm. So it is minus, I have taken minus, divided by 6000. Here if you see, the span they have given in meter, but sinking they have given in mm. So I have taken the value in mm. So remember, if one value is in mm, then you need to follow the same notation or same unit for all the values. So I have taken minus 10 divided by 6000. So if I simplify that, the MAB equal to 2EA by L, 2 theta A plus theta B minus 1 by 200. So this is the final value for MAB. Next I am going for MBA, because we have considered the member AB. So we have another moment is MBA. MBA equal to M of BA plus 4EA theta B by L plus 2EA theta A by L plus 6EA delta divided by L square. So here M of BA is 0 and I am commonly taking 2EA by L. So remaining is 2 theta B plus theta A plus, here also if you see the support is getting down, so the deflection or sinking is minus 10. So 3 into minus 10 divided by 6000. So the value which I am getting is 2EA by L plus 2 theta B plus theta A minus 1 by 200. So this is the value for MAB and MBA. So we have calculated for member AB. Next we need to calculate for member BC and member CD. So next we have taken member BC. So member BC means, if you take member BC, then let us draw the diagram. So this dotted line represents the straight beam, that is, this is B and this is C. And they have given that the B is sinking by 10 mm and C is sinking by 5 mm. So let us consider this distance as 10 mm and let us consider this distance as 5 mm. So if you take the sinking, then it will be like this. So the average value is nothing but 10 minus 5. So the average sinking is 5 mm. Remember, we need to, when two support sinks, when in a member, if both the support sinks, then we need to calculate the average. That is, we need to take the difference between the two. If it is in the same direction, so if it is in the opposite direction, then we need to add it up. Okay. So here if it is in the same direction, it is both the things moving, both the supports moving downwards. So we are finding the difference. So 10 minus 5 is the 5 mm. That is the average value. That is the actual sinking of the support when compared to B. The actual sinking of C when compared to B is 5 mm. So I am taking the MBC value. M of BC, we know the formula. So M of BC is 0. So 2EA by L, I am commonly taking the 2EA by L plus 2 theta B plus theta C plus 3 into 5. Because if you see here, B when compared to B, C is in upward direction. That is C is above B. So if the value, if the right support is upward direction, then it is positive. So I am taking plus 5. So if you solve it, we are getting MBC equal to 2A by L plus 2 into 2 theta B plus theta C into plus 1 by 400. So next I am going for MCB. MCB we have written the equation and we have substituted the value. Here also if you see that B is in, that is the left support is in downward direction and compared to right support, that is, or you can simply say that the right support is above or in the upward direction and compared to the left support, that is C is in upward direction and compared to B. So if it is in upward direction, so the value is positive, so I have substituted in positive value. So if you simplify that, MCB equal to 2A by L 2 theta C plus theta B plus 1 by 400. So this is the slope deflection equation for member BC. Next we need to calculate for member CD.